Namah Shivaya, Om Amrdeshwari Namaha. We are happy to have our next chapter, and that is chapter 12, Atoms. This is another exciting journey, especially into the modern physics, because as I told you in the last class, that not last class, during the introductory part of chapter 11, we had a discussion that normally the modern physics starts from the discharge tube and its related studies and all. Atomic physics, the origin of atomic physics starts from there only, because when they have an idea about how this discharge tube functions and discharge through the gases especially, opened a new vista in that science and technology, that is what is called atomic physics, and which we are going to concentrate for the next few classes. You know very well, etymologically, we had a discussion in class 10 also. Etymologically, atom means indivisible, because atomia means divisible, atomia means indivisible. But now we learned that atom is divisible, but at the same time, those days, especially in the 19th century and all, they didn't have much, early 19th century, much idea about the atoms and all. And those days, they thought that the atom could not be divided, but we have to look into the Indian school of thought that 2500 years before, the Rishi Canard, he described atoms. Even they say that in biography of Lord Buddha, the word Anu is used. Not only the Anu, we use the term Paramanu also. Even when they talk about the Prahlada and the conversation between Prahlada and Hiranyakasipu, there comes a word, Tunilumulan, Turumbilumulan, Anuvaisada Kurita, Konilumulan. That description, we say that when we divide the atoms into 100 parts, the one part can be called as cone, they used to say. Such a long tradition we have, but what we are going to learn is our the Western scientific thoughts one by one. But keep in your mind that we had a long tradition of discussion of atoms. And the first thing what we are going to learn in introductory part is, as described in the book, that in 1897, after the experiments of on electric discharge through the gases carried out by the English physicist J.J. Thomson, he revealed that atoms of different elements contain negatively charged constituents. Later they named as electrons, negatively charged constituents, that are identical in all the atoms, which means all the atoms will have electrons in general. Therefore, we can say that atoms, we all, even that time, they had a clear idea that atoms are electrically neutral. This could lead to some other opening also. If we consider that electrons are negatively charged one, we can easily come to a conclusion, since atoms are neutral, in atoms itself there are some positively charged constituents are there, positively charged constituents. And then how can we say that an atom must also have some positive charge in order to neutralize the negative charge? Then only atom as a whole can be neutral in nature. There comes a question, what is the constituents of the atom? What is the constituents of the atom? We can say that the first model of atom was proposed, as we said, J.J. Thomson in 1898. According to Thomson model, the positively charged positive charge of the atom is uniformly distributed throughout the volume of the atom, and negatively charged electrons are embedded in it. When we consider this J.J. Thomson method, we can explain a simplest scientific fact that atoms are neutral. Then there comes another, there are some other names also. How these electrons can be visualized? How do we visualize, or how can we see the seeds of the watermelon inside it? You, whether you cut it horizontally or vertically, you can see that the everywhere the red substance, that flesh will be there in it. What we can say that negatively charged thing, how we consider atom, like that negative, the seeds will be there. The seeds is seeds can be considered as seeds can be considered as, yes, you are correct, it is negatively charged one. And the red substance, what we have, no, that part, fruit of that watermelon can be considered as positively charged one. So we can have so many names, plum pudding model and watermelon model and all. But when the studies the advanced, they couldn't have the distribution of electrons. They simply said that electrons are embedded in it. But later studies revealed that there are some electronic activity in the atoms. And so what happened? Usually, J.J. Thomson method had a downfall. You can see that J.J. Thomson method, plum pudding model. Plum pudding and all, we are not having any direct experience. Very rarely we have this plum pudding and all. But we can understand that our substance, the sweet savory, which we call as pal payasam, how this in pal payasam, how we, the entire payasam can be considered as a positively charged one. And here in this photo which I have brought for you, it has cashews also. Forget about the cashews, you have to take only the dry grapes. How these dry grapes, even after frying in deeply fried in the ghee, it just, you know very well, you are all a biology student, it absorbs the ghee and it becomes very, what to say, spherical shaped grapes. How do we see the grapes in palpayasm? Like that we can see electrons in the uh, positively charged matter. This is the first part of introduction of atoms. The next part will follow later.